Hi, in this video we're going to be talking about the ion product Q. So the ion product represents the molar concentrations of the ions raised to the power of their stoichiometric coefficients. And the subscript 0 indicates that these are initial concentrations and do not necessarily correspond to equilibrium concentrations. So what does our Q look like? Our Q is going to be equal to product 1 A 0 times product B 0. Now let's take a look at the example. Alright, so we have PB 2 plus and S 2 minus. So the Q will be equal to PB 2 plus initial times S2 minus initial, and that's it. Now what does this Q tell us? So this Q is important because we need to compare it to the KSP and tell if we're producing precipitates or ions. So if Q equal KSP, then the reaction is already at equilibrium and the solution is saturated. If Q less than KSP, the solution is not saturated and more solid could dissolve to produce more ions. This is production of ions. And this one is at equilibrium. Now if Q is greater than KSP, it's gonna be superhydrated and to be producing more precipitate, which is our solid. Now let's do an example. Alright, it said predict whether a precipitate of PbI2 will form when 200 milliliters of 0.015 molar of PbNO3 and 300 milliliters of 0.05 molar NaI. So when these two substances are mixed together, will we form a precipitate? So will the Q be greater than KSP? And it told us the KSP of PbI2 is equal to 1.4 times 10 to the negative 8th power. Now first step is to calculate the concentrations of PbNO3 and NaI after mixing the two solutions together. So let's do M1V1. Alright, we have PbNO3 concentration is equal to 0.015 molar times 200 milliliters, which is equal to X molar times 500 milliliters. Now if we do 0.015 times 200 divided by 500, we'll get 0.006 molar. And next we have NaI. This will be the concentration will be 0.0505 molar times 300 milliliters equals new molarity times 500 milliliters. So 0.05 times 300 divided by 500 will be equal to 0.03 molar. Now both of these salts are soluble and will ionize completely. And then since this is the NaOH, the strong base, so Na plus is the weak conjugate acid, NO3 is HNO3 is the strong acid, so it's a weak conjugate base. So we can cross these out. So the concentration of Pb2 plus is this. The concentration of Pb2 plus is this, and the concentration of I minus is this. Now let's write our Q equation. Q is equal to the initial concentration of Pb2 plus times the initial concentration of I minus squared, because we have 2 moles. We have 2 moles of I2 for every 1 Pb. And since these are the initial concentrations that are mixed, this will be our initial concentrations for both. So Q is equal to 0.006 times 0.03 squared. And if you do 0.006 times 0.03 squared, you can get an answer of 5.4 times 10 to the negative 6. Now this is our Q. Let's compare it to our KSP, 1.4 times 10 to the negative 8th. So 5.4 times 10 to the negative 6 is greater than 1.4 times 10 to the negative 8th. So Q, this is Q. Q is greater than KSP. Q greater than KSP, it will produce more precipitate. So to answer the question, will a precipitate form? Will a precipitate form? And the answer is yes, because our Q is greater than our KSP. Now, what does Q greater than KSP mean? This means we have too much ions. And when we have too much ions, Le Chatelier's principle says we're going to shift the reaction to the right? PbI2 forms Pb2 plus I2 2I minus, right? When the Q is greater than KSP, that just means there's more ions than it should be at equilibrium, and since there are more ions, the reaction will shift this way, producing more precipitate. And we call this a supersaturated solution. Now, next question, will a precipitate form of MgF2 form when 6.00 times 10 to the second power milliliters of a solution that is 2.0 times 10 to the negative 4th molar in MgCl2 is added to 3.00 times 10 to the second power ml of 1.1 times 10 to the negative 2 molar solution. So will we form a precipitate? Again, it's the same question. Will be the Q greater than our KSP? And I told you that the KSP for MgF2 is equal to 6.6 times 10 to the negative 9th power. So let's see. We have 6.6 times 10 to the negative 9th power. Let's first use M1V1, right? So concentration of MgCl2 is equal to 2.0 times 10 to the negative 4th molar times 6.00 times 10 to the second milliliters is equal to, what's our new volume when they're added together? So 6.00 e to the second power times 3.00 e to the second power. It gives us 180. So when we add 600 milliliters to 300 milliliters, it's going to give us 900 milliliters. So it's going to be X molar times 9.00 times 10 to the second milliliters. So 2.0 e to the negative 4th times 6.00 e to the second power divided by 9.00 e to the second power will give us 1.33 times 10 to the negative 4th. Next, we have concentration of, this is NaF. So I missed this in the problem. So this is an NaF solution. So NaF, this will be 1.1 times 10 to the negative 2 molar times 6.00 times 10 to the second milliliters equals X molar times 9.00 times 10 to the second milliliters. So same as above, except this time, wait, no, not 3. This is not a 6. This is going to be a 3. This time it's times 3, and it's going to be 1.1 instead of 2.0. And this will give us a concentration of 3.67 times 10 to the negative 5th. So Q is going to be equal to, let's see, Cl is crossed out and Na is crossed out, so it's MgF. So it's going to be the concentration of Mg times the concentration of F squared. And now this is Mg, this is F. So it's going to be Q is going to be equal to 1.33 times 10 to the negative 4 times 3.67 times 10 to the negative 5th squared. So let's see, 1.33 e to the negative 4th times 3.67 e to the negative fifth squared. That gives us 1.79 times 10 to the negative 13th. What is our KSP? KSP is 6.6 times 10 to the negative 9th. So our Q is less than our KSP. That means we actually have more precipitates than ions, and it will end up producing ions due to the extra precipitate. And so to answer the question, will precipitate form? It will not. We instead will be forming ions. And that's it for this video on our ion product and production of precipitates. Thank you for watching.